Hello. So today we're gonna talk about, I'm gonna show you a new definition. So we spoke last time about, yeah, they are here. So about how to populate a simple surface or an area actually, and using the attractor concept. And we use this point as an attractor. Today we are gonna do a small variation. We're gonna have the same kind of area. Instead of having a point, we're gonna have a curve. And then this will be our final result for the first definition. Okay, so I'm gonna just move this up here and just focus on this one. So what I want you to do is just draw a random, really random curve. Okay, just editing a bit so it looks smoother. Okay, so all we're gonna import from Rhino is these two objects, the rectangle and this kind of SP line. Okay, so this is what we are gonna do today. Okay, we're gonna use similar to what we used before. We're gonna use the population, 2D population. So the idea is here we gonna populate this rectangle with those points. So we're gonna divide it kind of, and instead of the pattern that we're gonna create, instead of it's being affected by a point, we want it to be affected by this line. And it is something you can see in designs, modern designs like Zaha Hadid architects, for example, and other architects. They use this kind of methodology to, especially if we have pattern. So we're gonna start something similar. I mean, what you can do and what most designers do, if you have a bit from a previous definition, you can copy and paste. But since we are new in this, what I'm gonna do, I'm gonna turn this off, and then we can look at it if we need to. But in the meantime, what I'm gonna do is, so you can see here we have two curves. I'm gonna do two curves and I'm gonna do the population. Okay, so how do we get a curve? By now you should know how to get those curves. So they are orange because they don't have information, so they are just giving us some warning that this is empty and we need to add empty curve parameter. We need to add a parameter or value to it. So this is the first curve, and then this is the second curve. Okay, what I'm gonna do, I'm gonna add population, and we're gonna populate in 2D. Again, we can read, we can hover in our mouse around those, and this is the region rectangle that defines the two region 4. So it's, in this case, it will be the rectangle that we draw. However, as you can see, Grasshopper already decided how many points. We were not asked for that. So here, this is the count of numbers. I'm gonna put 100, and that will give me the slider. And then I'm gonna connect it to n. So here I can make it less or more. Of course, you can add more than 100. These are optional. So for now, I'm gonna keep them this way. Okay. And now what we are gonna do is we need to connect this curve. So last time when we did the point, I'm just gonna go back to the definition of the point. We connected those population, those points. So the output of this component, so it takes this rectangle and it kind of divided into those points. So the output here from the populate 2D, if I hover on it, it's basically the points, okay? And that's we connected with polygons, we connected with Voronoi, we connected with what else we did? Circles, polygons, we tried different also numbers of sides. And what we did is, as a reminder from last session, we did a distance. So the distance was between the point and the original point, the attractor, and the points of the population. In this case, it's different. So the curve is a bit more complex. So we kind of need to convert this curve into points. So what we're gonna do is we're gonna connect this curve here. So if I say curve, let's see what options of curves we have. Curve, which one we need? CP convert. We need, it's called, it's a converter basically. Curve. So I'm not gonna do the normal curve, but we need to look here what kind of options we have. And it is this one here, curve closest point. Okay, so let's hover on it. So find the closest point on a curve. So it's kind of converting this curve into points just to make this definition closer to the one we already worked with. So this one needs an input of a curve. So we're trying to convert this curve basically, but how it's gonna convert it, it's gonna take those points from here. So you can see now. So now it will measure the distance between the points on these curves and the other points basically. That's what will happen, okay? And there are some differences between the definition of the attractor point and now the curve. So like this is, we are introducing, this is a new component. So this is basically, yeah, choosing the closest points on those curves, okay? And what else? We're gonna do the flattening. So I'm not sure if we did that last time. No, we didn't use it. So the flattening is just making the output really, really simpler. And let me show you. And the whole idea is to create circles around those points that we are creating from here. Okay, so maybe I'll do the circle first, or we can, there's like few ways to go about this definition. So remember when we did a distance here between this point, basically between the point and the other points, we did a distance function. Here in this case, we will not be able to do a distance between each point on this curve and each point there. That will be like a lot of algorithmic work. So what we're gonna do is a domain of distances. Okay, so we're gonna give it a domain. Not this one, sorry. Not here. Domain. This one, the one on top, contains a collection of 2D number domains. Yeah, that's what I want. This one is to take from information from Rhino. So this is, and it's not the one as well. No, I'm looking for a battery one. Where is it? Domain. Wait for it. Construct. Let me write construct a domain. construct a domain, this one. So not, yeah, just the normal constructor domain. Yeah, this is the one I'm looking for. Why? Because it's giving me a range. Okay, so if I hover over it, construct domain, create a numeric domain from two numeric extremes, and that's what I want. I want to give this distances like numerical range, basically. Otherwise, it's going to be impossible to do the calculation, as I mentioned. So I'm going to do this. And then I'm going to do another number. Maybe we can do 1. And then connect it here. So this is, I'm going to use later for the distances between the points on the curve and the actual points from the population. Okay. So it's something I'm going to go back for in a bit. Okay. So far, I hope it's understandable. So we have two curves. We populated this area. For the curve, we created points on the curves, basically. And we used a domain that we're going to connect in a bit. This domain is giving us the minimum and maximum distance between the points. And now what we're going to do, when things get a bit mathematically kind of complicated, we use a something called flatten that we used also earlier in one of the definition. Okay, so that will just make the calculation easier. And we can see the output of it, the flattening, if we go here. So we have a tree of information. So information goes in. So we have 100 values, and here we have 100 locally defined values. Okay. And basically, what we need to do is now figuring out what definition we will put after. So if we look at the final definition, we need to basically remap those points. And so for them, so we need to create circles from these points. But before we do that, we need to kind of remap them on this area. But before we do that, we need to add bounds, and also it's giving me the maximum and minimum. So basically, it creates, as it says, a numeric domain which encompasses a list of numbers. So this is all to do with collecting the data from Grasshopper. Okay, and just really trying to simplify it. So now we have to, now when we get to the circles, and we're going to use the same circles that we have been using, that needs center and radius and normal vector. So the circle will be connected to the those points. So you can see now they have the same size, and for us, as we know, they should be affected by the curve, so it didn't do what it's supposed to do right now. And radius, we can, the radius should be connected to the domain, basically. So we're gonna bring it a bit closer, but before that, before we connect it, we're not going to connect it directly. We need something called remap. So we need an icon, not something. We need remap numbers, basically. And we need to connect also this. need to connect it basically with, so you can see here what we have. As I said, we are not going to put a slider number here. I mean, already Grasshopper decided what is the radius, so we can do that, but because we are working parametrically, we gonna eventually put connect it here. But before we do that, we need to put inputs. So the inputs of the remapping. So just let me give you an idea about this. Remap numbers into a new numeric domain. So it's also, again, it's about data organization. So we need to connect. So here we have points on the curve, and so let's look at the V here. So this is value to remap, and the output here. So I know it should be remapping from those values from the points on the curve, but let me see which output is better. I think the distance, yeah, because we are remapping from that distance. Okay. And then here, this one is the source domain, which is the numbers or the values after flattening. And then this one we're gonna connect it to the domain. So the remap is taking those distances. So this is the target domain basically. So it's taking this domain and remapping it. And then here, if you look at this one remapped number, it is the radius of the circle. So you can see when I did this last connection. So if I disconnect it again and you look here on the Rhino screen, that all the circles are the same size, while when we do the connection, we have different sizes of the circles. So we can turn those points off, which are those population, and we can turn the curve off as well. And we can change this, and you can see how this is affecting basically basically the circle's radius. Okay, so I'm gonna remap. We're gonna say again what we did exactly. So it's a bit more complex than before. So before we had a rectangle and we had a point. Now we have a curve. And so if I turn this curve off, what I mean the view of it off, I will still have this curve. Let me turn it off as well. So you can see how this is being affected by the curve. Let me show it again. If I take this point off, of course the points will change, and then you see I do something like that, just a bit extreme. Okay, and then here, don't forget that we can play with this domain. So this can get a bit bigger or smaller, also depending on what it shows here. Okay, so what we did is we took this curve, which is this one, we populated with points. We controlled how many points as well, so we can have less points basically, or more points. And then this is the curve that's going to affect the population. We connected it with something called curve closest point, which means we are finding the closest points on those curves, and we are using those to affect the other points, the population points. Now the information or the data, so we created circles from these population points, but the radius had to connect with a series of batteries that have to do with data organization. So after we get output from the curve closest point, we get a distance between base point and curve. So we get those distances, and we kind of flatten this data. We add it to a bonds, which create kind of a domain. So it's a domain of a list of numbers, basically. Okay, and then we kind of remapped all that to get also a range of remapped number that feeds into the circle radius. Okay, and then we connected the remapping also with the domain of maximum and minimum of radiuses for the circle. I'm gonna turn this off. So this is the first definition for today's session, basically. And you can see also snapshots of the main moments of this definition on the PDF.